Okay, today we're reviewing Chapter 5, Numerical Descriptions of Data. So first we want to look at SOCs. Remember, that's how we describe quantitative data for one variable. Shape doesn't particularly change in this chapter because there's no real quantitative measure of shape that we use in AP statistics. But you might note particular concentrations or large spreads of data in your box plots. Outliers. If your distribution is skewed, you're going to want to use 1.5 IQR. What that means is take the interquartile range, which is quartile 3 minus quartile 1, times 1.5, add that to the third quartile, and subtract it from the first quartile. That gives you your two fences. If you have any numbers above or below those fences, then you have an outlier. If your distribution is unimodal and symmetric, you might use 2 or 3 standard deviations above and below the mean instead of 1.5 IQR. But when in doubt, use 1.5 IQR and you'll be safe. For center, if the data is unimodal symmetric, use mean, otherwise use median. For spread, use the standard deviation if the data is unimodal symmetric, or you can use the interquartile range. Now, how do you make a box plot? So order your data from least to greatest, and then find the middle, which is the middle number or the average of the middle two. That's called the median. And then look at the data that are all to the left or below the median. Find the median of those. That's quartile 1. Look at the data that are above the median to the right of it. That would be, and find the middle of those. Again, averaging the middle two if you have to. That would be quartile 3. And then the 5-number summary is the lowest number in the list, quartile 1, median, quartile 3, and high. And you use those to make the box plot. The box goes from quartile 1 to quartile 3 with a bar at the median, and the whiskers go from the low to quartile 1 and quartile 3 to the high. And we can make these on the calculator up to 3 at once. So let's go look at that. Let's go make a box plot. Okay, so actually I'm going to make this second stat plot is on right here. Excuse me. So I'm going to shut that off for just a second and we'll go back into plot 1. Okay. So again, make sure anything in the y equals menu that might interfere with your graph is shut off, and make sure it's turned on. And then there are a couple different box plots on here. This is the one that shows outliers. This is the one that doesn't. So when in doubt, probably choose the one that shows outliers. And then zoom 9. And here's our box plot. Okay, we'll come back to that in just a second and see what we need to do to interpret that. Okay, so when you want to interpret a box plot, you can hit the trace button on the calculator, or just if you made it by hand, you're looking by hand. Remember that a box plot divides the data into equal fourths from the, up to the 25th percentiles, quartile 1, so on and so forth. Now, if each fourth is about equal in size, that means the data are equally spread in each of the quartiles. Now, if a fourth is particularly skinny, that means 1/4 of the data points are concentrated together in a relatively small range. So lots of data points are about the same at whatever that range is. If a fourth is particularly long or spread out, that means that 1/4 of the data is very spread out. Quartile 1 corresponds roughly to the 25th percentile, median to the 50th, quartile 3 to the 75th percentile. Therefore, the box of your box plot is the interquartile range, which is the middle 50% of the data. Okay, so let's go look at this box plot here. And so we can hit trace, and we can see the 5-number summary. So the minimum is -1, quartile 1, 3.5, median 6.3, quartile 3 is 8, and this is not the highest because we had it show the outlier. This one here is actually the high, the 15. But this number here is the highest one that's not an outlier, using the 1.5 IQR rule. And so if I were trying to describe this box plot, shape, well, not exactly unimodal, but it's not strongly skewed, okay? Because this isn't a histogram, shape can be a little hard to tell on a box plot. The main thing you're looking for is symmetric or skew. And this is a little bit skewed to the left, but then we've got this outlier over here, so maybe not. So sort of kind of symmetric, no dramatic skew. Outliers, yes, we do have one outlier, and that is at the value of 15. Now there's no context to this, otherwise I should be describing this in context. Now center, we have a median at 6.3. If I want the mean, I'll have to get it somewhere else, not in the box plot. And then in terms of spread, well, interquartile range is, let's see, the quartile 3 is 8, and quartile 1 is 3.5. So 8 minus 3.5 is about 4.5 for the interquartile range. And if we want the whole range, that would be 15 minus -1, so a range of 16. And so that's just kind of a rough analysis of this box plot. Okay. So now sometimes we want to compare and contrast two different sets of data, and so we might do that with two different box plots graphed on the same number line. And then what you should look for is what portion or percent of the data in one box plot is above or below the other, or above or below the median of the other. Is one more consistent or more spread out than the other? Look for big picture similarities and differences between the two groups. So let's do that now. I have a second set of data stored in list 2, and so I'm just going to go down and turn that on and make sure that I'm choosing list 2 here, and again the box plot. Now zoom, I'm getting this weird menu here, so I quit first and then I can zoom without having to deal with that menu. And there they are. So here are the two box plots. Now comparing and contrasting, this one here, it looks like, you know, this right here, up here, this is the 75th percentile. So more than 75% of the data are below the middle of the top one. So that's relatively interesting and worth noting. They both have high outliers. This one here, notice that there doesn't appear to be a low whisker. Well, what does that tell us? If you trace and down arrow to the second graph, the minimum and quartile 1, as you can see, are in the exact same spot. So that means 25% of our numbers are all ones. Okay, at least, because they're, you know, we don't know that that's exactly 25%, because some of these in this range here, between quartile 1 and the median, might also be ones. Of course, if we have the original data, we could calculate that exactly. And so we have kind of a small range down at this end. We've got 50% of the data between 1 and 1.6. Okay, so this data is definitely skewed to the right here. Okay, and so comparing and contrasting, these, you know, a lot of the data in this list are below this one here, but notice this does have a lower number overall. Okay, but when we're looking at the middle 50%, we kind of see something that might be almost statistically significant here, with the majority of this middle 50 getting down toward the end or below this one here. Okay, all right, and so what else can we do with data from Chapter 5, calculating percentiles? Order data from least to greatest. The percentile for a particular value is the number of values below that one divided by the number of data points. And it's not possible to be at the 100th percentile even if you're the best, because it's always the number of numbers below, and so it's never all the numbers divided by all the numbers. So if we wanted to calculate a percentile, I have already ordered this one here from least to greatest. Let's say I want this list ordered as well. Your calculator can do that for you. You just go to Second Stat Ops and choose sort A for ascending, sort D for descending. I'm going to do ascending, and I want list 2, and then I don't want this other stuff that's there. Delete. Okay. It'll just say done, and then I go into the list, and now it's ordered from least to greatest. And so now you can see all those ones. Let's say I want to know what percentile the 8 is at. Here's the 8. So it's the 15th number. So there are 14 numbers below it, and there are 16 numbers altogether. So 14 numbers below it divided by 16 total numbers puts 8 at the 87.5 percentile. Okay. Now notice that depending on the size of your list, you're not going to have every percentile possible, right? You'd have to have 100 numbers to have even coming close to having all the percentiles that are out there represented. So like when we go from 1 to 2.2, we might make a big jump in percentile, possibly, you know, like 5 or 10%, depending on how many numbers you have. If you have fewer numbers, you're going to make bigger jumps. Now, what do we do with all these different ones here? What percentile would those be at? That's a good question. It's kind of impossible to say that, you know, this one is at a higher percentile than that one. That doesn't make any sense because they're all the same value. And so in a way, they cover that whole range. So it wouldn't really be fair to assign a single percentile to these ones. Okay, if you wanted to, you could assign one to the lowest one or to the highest one and say, you know, at most, if we go back up the list here, we could say 1 is at the 7 divided by 16 percentile, and at least it's at the 0 divided by 16 percentile, because it could be the very first number in the list. So 0 to whatever 7 divided by 16 is. Okay? And moving on. So you can actually graph percentiles into a chart, and this is called the cumulative relative frequency graph, or an ogive. You can see some examples of that at the problems, the homework problems in Chapter 5 in your textbook. You put the data values on the x-axis and the percentile of those data values on the y-axis. So for example, if some data set has 50 miles per hour is a speed that's at the 45th percentile, then that would be a point at 50, 45. And so eventually the whole data set gets graphed. Often they come out in an S curve, you know, that starts lower left, kind of gets steeper, levels out a little bit, and then levels out toward the top. Okay, and so eventually when you get up over here to the last data point, you're at the 99th percentile or whatever, and down over here, you're at the low percentiles. All right, standard deviation is important to know how to calculate. It's even more important to know what it represents. So it's sort of kind of an average of how far a typical value in the data set is from the mean. It's not a true average the way we know it, arithmetic mean, because we square some numbers and then square root them, and then we're dividing by n minus 1 instead of n. But the general idea of adding up numbers and dividing by how many there are, you're sort of kind of doing that. And so it's almost a mean. It gives you a typical, you know, again, it gives you an average or an idea of how far a typical value in the data set is from the mean. Make sure you understand what standard deviation is telling you. To calculate it by hand, find the mean of your data, and then take each data point minus the mean. This is called the deviation for each of those data points. And so some of those are going to be negative because the value is below the mean. Some of them will be positive because it's above the mean. Square all the deviations so that the negatives and positives are now all positive. Sum them up, sum up all those squares, and then divide by n minus 1. And then because we have an exaggerated sum because we squared, now take the square root to unexaggerate it, and you have what's called the standard deviation. Now, usually you won't need to calculate that by hand. Usually you can use the calculator to do that. You can go to stat calc, 1-bar stats, and then just tell it what list you want the standard deviation for. And here's the mean of the list, 6.1125. Notice there are 2 standard deviations. When in doubt, use S sub x. That's the standard deviation for samples, 3.84. This one here is the standard deviation for populations. It's calculated slightly differently, but when in doubt, use S sub x. Okay, and so there's your standard deviation from the calculator, and hopefully you'll never have to calculate it by hand, but it's possible that the AP exam could have a question, you know, where you're asked to do a portion of this or show that you understand this. And so that, in a nutshell, is all of the numerical descriptions of data covered in Chapter 5, works in conjunction with all of the more visual or less numerical descriptions of data that we learned from Chapters 2 through 4. Okay, that concludes this video.